workshops, the contracts workshop. So we're going to be going over how to like manage and deploy contracts as well as how to interact with them. So we're going to build on a lot of ideas that we talked about last week with transactions, because deploying contracts is essentially just sending a transaction. There's a little bit more nuance in how you craft transactions to interact with contracts, but at the base level, contracts and interacting with them are just transactions. So I'm going to do something similar to what I did last week, where I'll share just like a basic JavaScript file where we're going to kind of do this vanilla with like the contract kit and then ethers as well to show how to do it at the basic level. Then we're going to go into how to do this using the truffle framework, which is pretty popular. And then I'll show how to interact with deployed contracts using the Celo extension wallet on a basic web page, so you get an example of that. And then touch on Remix and some of the tools around Remix that you can use for deploying contracts and interacting with them. So with that, yeah, let's jump in. So similar to last week, we're going to be importing a lot of the same libraries we were using for sending transactions, and we're going to use Web3, import the contract kit, and then ethers, and then the Celo wrapper.
Sorry, excuse me. You're currently showing the Zoom page. Is that what you intended to show?
No, it is not. Thank you for speaking up. I have so many options on Zoom. Okay, let's try this. How's that look? Does that look like some code?
We see code.
Excellent. All right. So yeah, this is the lesson.js file in the repo that I shared in the chat just a bit ago. So yeah, this includes like just a basic lesson JS file where we're going to do everything with basic JavaScript, and then I have a truffle repo where we can show how to do things with truffle, and then the web page repo where we show how to connect to the network and interact with a contract with a basic web page. Cool. So as I was saying, at the top of the file, we're just going to import these libraries that we were using last week: Web3, contract kit, and then ethers, and the Celo wrapper for ethers. And then .env library for importing our private key and our Figment API key for connecting to the network. So yeah, here we're just connecting to Figment, connecting our Web3 to Figment, so we have a connection to the Celo network. And then this line here where we are importing, well, actually, let me jump over to the actual contract that we're writing. So I actually have my contract in my truffle directory right now, but this is a simple, calling it hello world contract. This hello world contract just has a name. It's storing a name in contract storage. And then there's two functions. There's a get name function that returns the name. And then there's a set name function that accepts a string and then sets the name to a new name. So one of the most basic contracts we can write. So that's the contract we'll be using for the example throughout this workshop. And then in this build contracts directory, I have a compiled hello world contract. So I actually use truffle to compile this, but the main things that this includes is the contract name. It includes the ABI, which is short for application binary interface. This is basically tells the SDK how to read EVM bytecode and interpret it. So when you call a function on the contract, it translates the function call into encoded EVM data. So this ABI specifies that. We'll import that into our file for communicating with the contract. And then another useful thing is this bytecode. So this is what we will use, the code we'll actually use to deploy the contract. So we can just import it directly from this file, send it as a transaction. And then this file will also store deployed addresses of the contract. So when we run this deployment bytecode using a framework like Truffle, Truffle will actually save all deployed instances of the contract so we can reference them in the future. And if we're deploying on multiple networks, so if we're deploying on mainnet or any test nets, Truffle will keep track of all that information. So it helps us manage contracts as things get complex. So jumping back to the lesson file, we're just going to import this JSON file and call it hello world. So then we can start accessing these properties like the ABI and the deploy bytecode. From there, we're going to set up contract kit with our Figment connection, import our private key, add it to contract kit, and then set the default account. So then this is just initializing it so we can send transactions from the private key that we have. And I already funded this private key with Celo from the faucet earlier, so I can send transactions from this. But if you guys are cloning this repo, it's not going to come with environment file. What you can do is you can just run like node create account, and it will print new private key account address, and you can just paste that into a new environment file, and you guys will have that for running through this if you guys want to. So now that we have everything set up, we can just go through a basic contract deployment. We're going to deploy the hello world contract with this one function. Outside of the function, we're just going to set a variable, the contract address, and then a hello world contract instance so we can save it as these get deployed. But this transaction here that we defined is essentially all it takes to deploy a contract. The things to note here, there's only two fields you have to define. The data, which is the actual bytecode for the deployment, contract deployment, and that's what we're getting from the JSON file. When we compile our contract, it comes with some deployment bytecode already crafted, so we just call hello world bytecode as the data, and when we send this transaction, it's set up to create a new contract. And the thing that tells the EVM that this is going to be a new contract is there's no to address. Normally when we send transactions, we're specifying an account to send the transaction to, but when the transaction is to no account or the zero account, just an account that's all zeros, this indicates to the EVM that this is going to be a new contract deployment. So once we have that transaction crafted, we just call send transaction, wait for the receipt. And I have to actually call the function. So this will print the receipt, and then it's going to print a link to the block explorer. There's just one thing I want to show in the receipt. In the receipt, there's this contract address field. This is the address of the new contract that we just deployed. So if I actually go to the block explorer, I have to share my full screen. So I'm going to stop sharing for a second. I'll just share my whole desktop. You guys seen the whole desktop?
Mm-hmm.
Cool. So yeah, we see a contract creation transaction 41 seconds ago with all of the information that's specified here. So it's, yeah, brand new contract. And it's at the address that we see in the receipt. So at the most basic level, that's all it takes to deploy a contract. You can imagine as we go through doing more actions on our contracts, and we want to like save the deployed addresses and interact with contracts on multiple networks. We want to use a framework to make this easier. But before we get into using the framework, let's just go through the rest of like the basics of interacting with this contract we have deployed now. So just going over how to read a contract, this contract has a state already when we deployed it. So it already has a name of Celo in storage when we deploy this contract. So we can actually read that data already once the contract's deployed. So in this read contract function, I'm just calling deploy contract again to get a fresh hello world contract. And then using contract kit, I'm going to initialize the contract kit to use this deployed contract. And there's this function. I can just set up a new kit.web3.eth.contract, which is a contract object defined in web3.js. Contract kit is using web3.js under the hood, so we can just access this function. And to interact with a deployed instance of this contract, we just need the ABI, which is that interface that specifies how the SDK is going to encode transactions to get specific functions. And then there's the interface and then the contract address. So where is the contract on the network? And since we're interacting with a version of Web3 or contract kit that's already initialized with the Alpha Horus testnet that we specified above when we set up the file, like this instance of contract kit already knows which network we want to talk to. So we're talking to the Alpha Horus testnet at a specific contract address with a specific function encoding scheme specified in the ABI. So once we have that hello world contract instance defined, we can just call the method get name to get that name, because we have a function called get name defined in the hello world contract. So we just call, this is the syntax for doing that. You just call the contract .methods.get name .call, and that will return the name. So let's just run it and test it out. It should just say hello world stored name is Celo. Yep. There we go. And this output printed above is just another deployment transaction, deploying another hello world contract. So yeah, reading a contract is easy as just calling a function on the SDK after you initialize the contract. So the next step after we read the contract, we're going to want to be able to update the state of the contract. So we show how to do that in the update contract function. The top of this is just calling the read contract. So we are going to deploy a new contract, read the state, should print Celo, and then we're going to craft this new transaction on the hello world contract instance that we defined in read contract. And we're going to set the name to hello Celo camp and just specify the from account, which is our account that we've set up as the default account for contract kit. So once we have that, wait for the transaction to be mined on the network. We're going to print some details about that transaction, and then it's going to read the new name once it's added to the network. So, kind of uncomment the function. So this is the deployment transaction. You see the hello world stored name is Celo, and we just got a new receipt. And we have an error here. So it looks like it was reverted by the EVM. I was having some trouble with this earlier as well. Sometimes it's working without specifying gas, and sometimes it's not. So when you call like the contract instance and then the function that you want, you'll call .send after the function that you want if it's a transaction. In this read call, we just call the function and then call, but in a actual sending a transaction, we call the function and then send. So that's the difference between reading and sending. When we send, we can also specify transaction options within the parentheses of the send call. So that's where I'm specifying from. And I was avoiding this error earlier by just specifying the actual gas to send the transaction. So let's try that again by specifying just 200,000 gas. Should be more than enough. Yeah, so that made it work. I might need to file an issue with the contract kit in the contract kit repo just to indicate sometimes this gas fails. But if you hard code the gas, or you can actually programmatically get a gas estimation, but just specifying the gas here because the gas estimator in the SDK looks like it's sometimes failing, but specifying it will get around this. So yeah, that's like the basic of how we can update the contract. Does that make sense to everyone? Any questions? I'm not really checking the chat, so feel free to speak up if you have anything.
Josh, quick question on the contract deployment. So
Yep.
in one of the tutorials on Figment, it talks about using truffle, right? And I'm just trying to understand what the basic differences are between using that method versus deploying it the way you've shown us.
Yep. I'm going to go into truffle in a little bit. I'm just going through like the basic examples, but real quick, truffle, the main thing truffle does is like when you're running these transactions, all of these outputs, not all of them, but like some of the outputs that you may want to reference in the future will be stored in a file like this. So then if you want to reference like all your previous deployments, that's stored in an additional file. You'll get more metadata around your deployments. There's also like versioning that truffle will take care of through smart contracts. Yeah.
Got it. Okay.
Cool. So yeah, I just want to go quickly over how to do the a similar thing, ethers, because I know ethers is a very popular library for Ethereum development. This is almost exactly the same as the transactions section we went over last week, but the biggest thing here is just we like above, we just specify null as the to address, and then we pull in the hello world byte code as the transaction data. And then, yeah, wait for the receipt, and then we can print it. I'm not actually going to run this because it's just going to print the same stuff. This is just here for an example. And then with ethers, just initializing a contract is a little bit different than with Web3.js or contract kit. So let's call new ethers.contract. We're again passing the contract address, the hello world ABI, and then we're specifying the ethers wallet that we're going to initialize this contract with. So in this ethers wallet, we are indicating that we're connecting to the Alpha Horus testnet, which we set up here. So then we can just call hello world contract.getName. That will return Celo. And then for writing with ethers, again, you just can call hello world contract.setName and then pass the string that you want. And then you can pass transaction options as an additional parameter to the setName function. So you don't have to call like setName.send. You can just call setName, and then the second parameter is an object that accepts these transaction parameters. So in this example, I just set the gas limit to 200,000 like above. Just a little bit different syntax, but you get the same effect. So that's the basics of just using the basic SDK for deploying contracts. Let's go into Truffle and see what differences we have there. So Truffle has a bit more structure to how it works. It's a smart contract management library. So when you actually initialize Truffle, you'll like if you just call Truffle init and you have Truffle installed, you'll get a contracts folder that actually comes with this migrations.sol file. And this is actually a smart contract that Truffle will deploy when you first run any contract migrations. And this contract just helps keep track of the versions of your contract and the last time you migrated. So it's just a contract that Truffle will track and help maintain your migrations. And basically, if you are editing your contracts and deploying new versions, if there are no changes or anything, Truffle won't migrate new versions. It will only migrate contracts if they've been changed when you run migrations. So this is where we have our Hello World contract defined in our contracts directory. So like if we just run Truffle compile, it's probably not gonna, yeah, it didn't compile anything because we haven't made any changes here. So let's just change our contract a little bit. We'll just change the storage variable on deployment. We can call Truffle compile again. And it should compile our new contract. And this will generate new deployment bytecode. And lets us know what version of the Solidity compiler it used. So when we compile this contract, Truffle will actually store, it's called the Truffle artifact in the build/contracts directory, and this is similar to the JSON file that I showed you before, but it includes the ABI, the deployment bytecode, and then it also includes towards the bottom of the file, there's this networks section, and this is actually where it stores all of the information about the networks that it's deployed on, the addresses of those deployed contracts and the transaction hashes of those deployment transactions. So if I run Truffle migrate, I'm going to deploy to Alphahore's network. And since this is actually a new version of the Hello World contract, because I made that edit earlier, it didn't update. Sometimes if you run migration, run Truffle, I don't know why it doesn't track these updates, but you can just delete your build directory and run it again, and it will come up with the latest migrations. But let me keep going through the structure of the Truffle framework, and we'll get back to this. So I just ran Truffle migrate, and I specified a network of Alphahore's. So when I run Truffle migrate, Truffle's actually going to go through these migration scripts that are defined in the migrations folder. So initially, it comes with this file, which is just the initial migration file. This is going to deploy that migrations contract, which helps track migrations. And then typically, you'll create a second file that's a deployment script for deploying your contract specifically that you wrote. So in this one, I'm pulling in the Hello World contract, and then I'm just specifying deploy Hello World. So when I run Truffle migrate, it's going to run through this script and try and deploy Hello World. The second part of this migration command specifies which network I want to deploy on. That's specified in the Truffle config.js file. So in this file, I can say different networks that I'm working with. So you could actually specify Ethereum networks here, Celo networks, any EVM-based network, or any network where Truffle works. You can include information for all of that. So you can see here I have the Alphahore's network defined, where I just specify a provider where I'm using contract kit, and I also have, I'm calling it mainnet. This is Celo mainnet. I'm including the Celo mainnet chain ID, and then also the contract kit provider. So there's a little bit more configuration needed for this Truffle configuration file specific to Celo, and that's just setting up this contract kit current provider. And up here is just some of the code to set that up. And this will look familiar because it's similar to what we've been using for transactions in the lesson.js file. But we're just pulling in contract kit, Web3, the path to our private key file. setting up Web3 with Figment, setting up contract kit with our Web3 connected to Figment, getting our private key, and then adding a private key to contract kit so we can actually sign all of these deployment transactions with Truffle. So let me actually, I'm going to delete this build contracts folder because it's stale now that I updated the Hello World contract. So if I run Truffle migrate and specify the Alpha Horizon network, we can see what Truffle's gonna go through. So it's compiling everything, just put it in the build contracts folder. Now it's giving me deployment information for the contract. So it just deployed the migrations contract. Here's all the information about transaction hash, contract address, how much it costs. And now it's running my deploy contract script where it's deploying Hello World and printing the same information. And all of this data is stored in these Truffle artifacts in the contract JSON files. So yeah, that's basic overview of using Truffle for running deployments. One thing to note is Truffle does have like a pretty robust framework for like testing contracts. I haven't gone too much into this with building on Celo because the default local development chains for Truffle are Ethereum development chains, and since Celo has different transaction objects, you can't make the same assumptions about how the network's working. There's actually some key differences because Celo transaction objects are different than Ethereum transaction objects, and depending on what you're testing, it may or may not be a good environment for testing your contracts. So if you guys want to use Truffle for testing your contracts or use Ganache for local development, yeah, just reach out to me and I can help you assess whether this would be good for testing. We are working on a version of Ganache that supports Celo transaction objects and like the more basic features of the Celo network, like paying transaction fees in CUSD. And once we have that like production ready, then you can just run your Truffle tests on that local development network. An alternative option is to run any tests that you write with Truffle directly against the Alpha Horizon testnet. So every test transaction will just be happening on the live Alpha Horizon network, and then you have you have those guarantees that like the similarity with Celo mainnet around like how the network's actually working and the protocol contracts that are deployed there. The one drawback of running all your tests directly on the Alpha Horizon testnet is there's 5-second block times. So if you have like hundreds of unit tests that are deploying or sending multiple transactions to the network, they can take a long time to run. But that being said, having tests that are slow is better than having no tests at all. So that's what I've got for you for Truffle. Any questions on Truffle? Cool. I want to jump over to, well, before I jump over to Remix, I just want to go back to interacting, like how would you enable a user to interact with this contract on a web page? This is gonna be very similar to the section last week on using the Celo extension wallet for just sending transactions. But we're gonna pull in some of the ideas from encoding function calls to smart contracts. So let me run. All the interesting stuff is in index.js. So yeah, here's our simple web page. Let me make this a little bigger. So there's just 2 buttons, an input, and then there's the display of the name. And we connect our extension. This is already connected, so it should just pop up with a name. Yeah, our contract is currently storing the name Lala. We can set it to hello Celo can. Let's set it. Pops up and asks if we want to send the transaction. Confirm. We're going to wait for this transaction to be included, and it's just going to auto update. So that's when the transaction is confirmed, it's just auto updating the UI to show the new storage value. So we'll just go over the concepts of like initializing the contract, reading the contract name, and then setting the name, but in the context of a web browser. And it's going to look almost exactly the same as in lesson.js because we're just doing this in JavaScript. Just a little bit different setup with the extension. So we're going to import Web3 and contract kit. We're going to grab that truffle artifact, the hello world JSON that has our deployment information. And then we'll just like jump into our functions. So first we want to connect our Celo wallet to our extension. This is the same as last week where we're just getting the injected Celo object, creating a new Web3 object, initializing contract kit, getting the accounts, getting the chain ID of the network. So this will let us interact with mainnet or Alpha Juarez, depending on whichever network the user's interacting with. I'm on Alpha Juarez right now. And then we're just going to initialize the contract like we did in the other script, where we just pass the ABI, and then we're going to pass the address of the deployed contract. And so we're going to get the hello world JSON in the network section of the chain ID of the user, and then just get the address. And once that is initialized, we can call get name, where we just run that same function that we defined in lesson.js, where we just call hello world contract.methods.get name, and it will display it. I just have another button linked to set name where it's just going to grab the input of this text, grab the value, send it to the contract encoded according to the ABI. And again, here I'm specifying this is coming from the default account, so the first account from the Celo extension wallet, and then specifying how much gas to send. So this is, yeah, just a basic example to show how you can connect like desktop-based apps to contracts. It should be pretty straightforward. Any questions on this?
One question on the ABI side of things, right? So it seems like the JSON that is, I guess, compiled might be slightly on the larger end for certain contracts. So I'm wondering if there's a way to like prune some of it out, maybe some key values that are not like necessary or something, or do you need the entire thing to be there?
It's actually not that large. I mean, there's a bunch of data here. I honestly don't know what a lot of the data that Truffle's tracking here is. But in terms of like the size of a web page, this isn't that much data. I don't know if I can easily inspect the size of this. But certainly, like if you don't need if you don't need all of this data, you can definitely just like trim it and get what you need, or only host certain parts of it in your web app. So like you could just grab the ABI and the network address, and you could just serve that in your web application. So users are just interacting with that. It's certainly possible.
Got it. Okay. Yeah. And another question, which is related to use contract kit versus like contract kit itself, is I was trying to like integrate, just sort of run a basic integration. And one of the things we are trying to enable is sort of signing a user in, right? And obviously when you sort of click on connect wallet, you get the wallet address and stuff. But it seems like in our particular application, given that some of the data also needs to be stored off chain, we're trying to sort of authenticate the user. And one of the methods that I was just reading about was that you could have the user sign a random value. You can send that to the server, and then you can compare those values. But it seems like as of right now, use contract kit, that function does not work with the extension wallet over LoRa. So I was just wondering if you had any suggestions on like alternatives to that.
Yeah, I think Alex has been working on that. He said it works with just importing the private key, but I know that's not something you're going to have average users do. I think this is supported with Wallet Connect. So I'm hoping we do get this published in the next week, but I don't know. Maybe we can follow up after and we can figure out the best way to just like sign arbitrary data using use contract kit. Yeah, we could connect with Alex and also see what work needs to be done there. I don't know if it's on the extension wallet side or if it's on the use contract kit side, but that's definitely.
Okay. I'll just send you a message right after then. Yeah, thanks.
Perfect. Cool. So yeah, I just want to go over Remix pretty quickly because Remix is a really cool tool for just like prototyping, quickly writing Solidity contracts and deploying them to the network. Remix supports importing a lot of contract types from GitHub. So if you just find contracts that you like audited contracts, like OpenZeppelin has a big repository of contracts that you can import directly into Remix and just deploy them directly. So actually, let's do that. Let's see if I can. I have some OpenZeppelin contracts imported from GitHub, and I'm just gonna like pull up the ERC20 contract and just see if I can compile it quickly. So to get Remix is like a very powerful web IDE. It includes lots of stuff. It mainly supports Solidity, writing contracts in Solidity. I'm pretty sure it supports Viper as well. But I haven't been writing contracts in Viper recently at all, so I've been sticking with Solidity. And yeah, there's lots of options here in terms of where to get more support, where you can import contracts from. There's a bunch of options on the left where we have like a file tree of contracts that it will save contracts that you've been working on directly in the browser. There's a compiler where you can specify the version, your language. You can deploy and run transactions locally. This is for an Ethereum specific environment, so I haven't been using this much lately with Celo. But there is a like rich system of plugins for Remix, so you can extend the functionality of Remix. And to get Celo working with Remix, you actually need to activate the Celo plugin. And this will make Celo transactions work directly with Remix. But there's a bunch more stuff that Remix can help you with in terms of like getting insight into how your contracts are created, debugging, tutorials. There's a lot of learning resources here. But I'm just going to focus on using the Celo extension. So to get Remix working with the Celo plugin, you actually need the Celo extension wallet. This is how it's going to connect to the Celo network. But yeah, let's go back to compiling an ERC20 contract. Looks like everything's compiling fine, no errors. Yeah, the IDE has like really good syntax highlighting and will let you know if like anything's not working, and the compiler will actually flag specific areas in your code where things might be breaking. So it is a pretty good place to write first drafts of contracts and get quick feedback on what's working and what's not. And once your Solidity contract is compiled, we can go over to the Celo plugin. This is already connected to my Celo extension wallet. Before you connect it, there's just a button here that says connect, and it will give me my balance, my network, and compile ERC20. Looks like I already have, oh, this is a storage contract I deployed earlier. I'm going to remove that. But to deploy a contract, I can just click deploy. It's going to prompt me to send a transaction. And then once this contract is deployed, it's going to pop up here and show me all the functions available on this contract. Whether they're like call functions for reading contract state or transaction functions like for sending transactions to the network. So these are all functions that are available on the ERC20 contract. Looks like I didn't specify any of the inputs yet, so it's not there. But Remix just makes it really easy to get started deploying contracts and interacting with them. It's also useful like for it's not a super easy interface to get started with, but for like if I have an ERC20 contract already deployed on the network and I know the interface, I can actually drop the source code directly into Remix, compile the contract, and then instead of clicking deploy, I can click at address, which will just give me this interface for interacting with an already deployed contract instance as opposed to deploying a new one. So you can actually do this with any ERC20s on the Ethereum network. Like you can use this as an alternative interface for interacting with contracts and reading their state on any EVM-based network. So that connects with Remix. But yeah, this is a really great way to get started and just explore deploying and interacting with contracts. I do want to show this interface real quick as well. This is on the Open Zeppelin website, and it's kind of like a contracts wizard for creating ERC20 or ERC721 contracts, and it integrates directly with Remix. So if you guys are interested in deploying an ERC20 or 721 contracts, you can actually do this with a no-code interface. And it kind of gives some insight for people that are less familiar with Solidity or writing contracts, gives some more color into like how things are actually working under the hood. So we can actually create a Celo camp token right now. And it's just, you can see the code's just like being filled in on the side here. We'll create 10,000 tokens. We're gonna make it so we can create new ones. We can pause this, and we'll give additional access control roles to who can do what functions on this contract. And we can see all these, all the appropriate Solidity got added to this contract. So if we decide we want to create this contract with these parameters, we can just click open in Remix, and it's going to pop open Remix with all of this code pre-filled. And I can jump into the compiler. Looks like it worked. And then connect to Celo extension wallet, deploy the contract. It's going to pre-fill everything, and let's hope this deploys in a second. So we can see it already says this is the Celo camp token. And now we can start distributing this to all Celo campers. So yeah, really, really cool tools to get started deploying tokens or creating custom ones. And you can extend any functionality that's automatically pre-filled here. So yeah, I see we're coming up on time. But you guys have any questions on Remix? Remix is a really powerful tool. I highly recommend just starting to play with it and exploring what functionality is there, because that's the best way to learn it, honestly. And yeah, that's pretty much all I have for you guys today. Any questions about Remix or any questions about anything that I covered earlier or how any of this fits together or how you guys might be able to use some of this?